Hello and what's up, everybody? It is the end of the year, and we are starting our review for the finals. And today is part one. Yes, part one, because we have 5 parts to this. So let's get started. Our first one says right triangle ABC has vertices A at 0, 0. So let's say A is here, right? That's point A. And then B at 4, 0, which means it's to the right of A. B right here at 4, 0. We want to figure out where point C is. So this is at 0, 0, and this is at 4, 0. The first one says any point on the line x equals 4 except where y equals 0. So x equals 4 is a dotted line that goes up and down right here where B is. And where y equals 0 is point B. So this is actually our answer on the first try, because if we put our lines out anywhere here, right, anywhere here, these would all create right triangles, right? Even if we go down, no matter where these lines go out, would create right triangles. So we are good to go. Next up, says the equation y equals -1 is graphed on the coordinate plane shown. We can see that line right here. It might be hard to see because they're both black lines. We got a lot of black lines here. It says graph a line perpendicular to y equals 1 that passes through 6, 4. So where's 6, 4? We go over to 6 up to 4. That's the point right here. And if it's perpendicular to y equals -1, that means we are going up and down here like so. Obviously, my drawing is not perfect. Line. But that makes a perpendicular line, 90-degree angles. And then we want to graph a line parallel. So let me change my color. A line parallel to y equals -1, which here's y equals -1. That goes through -4, 8, which is right here. So if it's parallel, it's going to go horizontal. My first line is vertical. My second line is horizontal. Let me just mark this off. This is the line there. The blue line is for B, and the red line is for A. Next up, it says write the equation of the line parallel to y equals 4x plus 3 that passes through point -2, -3. Well, what we need here is point slope form of a line. And point slope form looks something like this. Y minus y1 equals m, which is my slope, x minus x1. Now, m is right here. The m of my first line, m equals 4. And parallel means we want the same slope. So we're going to use m equals 4 here too. And then this is my x1, and this is my y1. So let's write this line. So we first write, we get y minus a -3, which would be +3, equals m, which is 4, times x minus a -2, which will be +2. Now we just want to simplify and solve for y. So we get y plus 3 equals 4x plus 8. We have to distribute. Then I subtract 3 on both sides, and I get y equals 4x plus 5. And there is my equation. Next one, perpendicular to this line. Well, my slope for this line is -3. When we're perpendicular, we have to write what we call the opposite reciprocal. Remember, we flip it and change the sign. So the slope we want to use for this problem will be 1/3. And then my point is x1, y1. So when we plug this in, we get y minus 3 equals 1/3. Sorry, mix that up. Y minus 4, and then x minus 3. We multiply this out. We get y minus 4 equals 1/3 x minus 1. Add 4 both sides, and we get y equals 1/3 x plus 3 as my equation. And that line will be perpendicular to the line given, and it will go through 0.34. Next up, this analyze quadrilateral ABCD. First of all, we want to determine the length of each side of the quadrilateral. Well, one thing we could tell about this quadrilateral is that it is a square. So that means if we find one side, it'll tell us all the sides. But with that, we need to know our distance formula. And our distance formula, d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. We just need to fill these points in with coordinates. So I'm going to use B and C because they're just both positive and I like positive coordinates. So B is at 3, 6, and C is at 8, 2. So let's plug those in. Also, let's label them. We got x1, y1, x2, y2. So we plug them in. We get D equals the square root of x2, which is 8 minus 3 squared plus 2 minus 6 squared. And we're just going to plug this right into our Desmos scientific calculator. 8 minus 3 squared plus 2 minus 6 squared. We click enter, and it gives us the length of the sides. D equals about 6.4. And that's going to be our answer for A. Now it says determine the slope of each line. Well, let's write this as starting with AB. So AB, the slope of that line, we go, remember, it's rise over run. So we go up 1, 2, right 1, 2. Or sorry, up 1, right 1. Which means it's just our slope is 1. And then our slope for BC is -1 because we go right 1, down 1, right 1, down 1, or down 1, right 1, down 1, right 1, because it's rise over run. And that down 1 makes it negative. And then watch, CD is going to be the same as AB, which is 1. And then AD will be the same as BC, which is -1. And then it says, determine if the quadrilateral ABC best describes which, and it's going to be a square. Why? All sides are equal and adjacent sides are perpendicular. Boom. There's our reasons. Next up, it says analyze rectangle STUV. Explain how you could transform rectangle STUV so that point S prime is located at the origin, and then graph rectangle STUV on the coordinate grid and list its coordinates. Well, we want to get S to the origin, which is here, which means we want to move it down 1, 2, 3, 4. So we want to move it down approximately, well, if each of these lines is 25, so we go 25, 100, 100. Okay, so we want to move it down 100 units, and then to the right 150 units. So the way we do it is down 100 and right 150. And if we graph this, it's going to look something like this. This is going to be S prime, D prime, 1, 2, 3, 4, 5. We go 1, 2, 3, 4, 5. U prime and T prime. Connect it like so. There we go. It says calculate the perimeter of triangle STUV. Well, the perimeter is easy. We just count. But we need to remember each of these dashes is 25. So we go here. We go 25, 50, 75. So this is 75, which means this is 75. We go 25, 50, 75, 100, and 25. So 125, which means this is 125. So now we just add all this up. So we get 75 plus 75 plus 125 plus 125, which is going to equal 400. Now we need the area, which means we just do the length times width. So 75 times 125, which we go to the calculator. And it gives me 9,375. There we go. Nice and easy. Next up says analyze this figure, and what we want to know is the perimeter. Well, a lot of these lines we could just count, right? So for instance, we know that each marking is 2 units. So we go 2, 4, 6. This is 6 units. We could go 2, 4, 6, 8, 10, 12, 14, 16. 16 units right here. This one's 2, 4, 6, 8, 10 units. 2, 4 units. We go 2, 4, 6, 8, 10 units right here. And then all our other sides, we need to figure it out, right? So for instance, JA, line JA, right? J is at what coordinate? 4, 6. And then A is at 10, 10. So we're going to have to use the distance formula here. D equals, then we get x1, y1, x2, y2. We plug everything in. Square root of x2, 10 minus x1, 4 squared. Y2, 10 minus y1, 6 squared. And what do we get here? We just plug it into our calculator. 10 minus 4. Whoops. Forgot my parentheses. 10 minus 4 squared plus 10 minus 6 squared. Give me 7.2 units. So we now know JA is 7.2. Next up, we have to find DE. Let me change my color here so not everything blends in. So we get DE next. What is the coordinates of D? Coordinates of D is at 10, negative 6. 10, negative 6. And the coordinates of E is at 4, negative 4. And now we plug these in. So we got the distance formula is the square root of, forgot to label, x1, y1, x2, y2. And what do we do here? We go 4 minus 10 squared plus negative 4 plus 6, because a negative minus is going to cancel, right? And now we just plug this into our calculator. Square root 4 minus 10 squared plus negative 4 plus 6 squared equals, this is going to give us about 6.3. So this is going to be 6.3. And we have one more right here. HI. So let me change my color one more time. HI equals the square root. HI. We want to write the coordinates. H is at 4, 0. 0. And I is at negative 2, 6. We plug these in, we get D equals the square root x1, y1, x2, y2. So we plug this in, we get -2 minus 4 squared plus 6 minus 0 squared. When we put this in our Desmos calculator, we get the answer of -2 minus 4 squared plus 6 minus 0 squared. Enter. We get about 8.5. So now we know that this is 8.5. And all we have to do is add all of this up. So what is that going to look like? Let me change my color again. We add all this up. So I'm going to start at the 4. 4 plus 10 plus 8.5 plus 6 plus 7.2. Now I'm going to have to come under plus 16 plus 6.3 plus 10. And we went all the way around. So let's plug this into our calculator. 4 plus 10 plus 8.5 plus 6 plus 7.2 plus 16 plus 6.3, finally plus 10, and that all comes together to equal 68 units. So all we had to do was use the distance formula here, make sure we know our units are correct, and we are good to go. And that's the end of part 1. Good job. Make sure you take notes, ask questions if you need it, and I'll talk to y'all next time.